Thank you for joining me for this video. I am Strish. I hope all of you are doing well. I have a question here provided to me from a particular viewer. I'm not examining it from the lens or the perspective of if this is a practical question by any means. It could be hypothetical, but this is the question the viewer provided to me and I want to answer it for all of you here in this video. The question is a chemistry one. If 2 grams of hydrogen sulfide gas reacts with excess sodium hydroxide, what volume of water is generated? That is the question. Again, it could be practical, it could be a theoretical, or it could be a hypothetical scenario. Either way, we are answering it for that viewer. How do you proceed here? Start with a reaction. Hydrogen sulfide gas, H2S gas, reacting with excess sodium hydroxide. Anytime you see the word excess in a question, you're not worrying about limiting reagents. Plus sodium hydroxide, which you can always write as aqueous, because that indeed is what it will be. Aqueous will generate water, and let's see what remains. How about this? Sodium sulfide. We will put this here in the aqueous form because you will find out it will be. But when you balance it, you have a 2 over here, and what do we end up seeing over here? Well, 2 sodiums, 2 sodiums, 2 oxygens, 1 oxygen. If I put 2 over here, everything is balanced. 4 hydrogens, and it looks good. When you're looking at this may not represent the reality of the reaction, because when you start tearing it apart for net ionic reaction, what you end up seeing is you have a hydrogen sulfide gas. Ignore this nomenclature, but I have 2 sodium ions and I have 2 hydroxide ions. Here I have water, and then here I'll have sodium, or you can better write it as this, 2 Na+, and then obviously your sulfide, and that right there represents the breakdown of this reaction. The items which remain are this and this. Your real reaction is hydrogen sulfide gas giving rise to 2H2O. It doesn't have to demonstrate a balance over here because many of the items are represented here in terms of the balance above, but they're not brought down here. This is the reality of the reaction. But how do we answer it? We have 2 grams of hydrogen sulfide giving rise to water. How much in terms of volume? I have 2 grams. So this is how you do it. 2 grams of hydrogen sulfide gas multiplied by 1 mole. Each mole of this is equal to 1 in terms of its molar mass. This is 32 plus 2, 34 grams H2S times. Now we have to bring in the water. We have 2 per 1. You have 2 moles of water being generated per each 1 mole of hydrogen sulfide. Now bring in the molar mass of water to get rid of this moles. I have 18 grams of water per mole of water. When you look at everything, this cancels out with that. The mole of H2S, I should have written it H2S with that, and then mole of water with that. The only thing which remains is grams of water. You multiply 18, you multiply 2 and 2, and you divide by 34. And let's do it. You have a 2 times 18 divided by 34. I end up seeing 2.11 or 2.12 grams water. 2.12 grams of water, but we have to convert grams of water into volume, and you can. Density factor. Density, you know, is equal to mass over volume. Volume here is equal to mass divided by density. If the density factor for water is 1, and you know grams is proportional to milliliters, just as kilograms is proportional to liters in terms of the density factor, and for water, this is a very proportional unit conversion, then you can easily do 2.12 grams is equal to 2.12 milliliters, and that would be for water, the volume of water generated from this reaction, and you would be done. And that right there would be our answer, and it should be right. Thank you for watching.